All right, this is page 260, use substitution. There will be two versions of these videos. One version will be using pattern recognition. The other version will be using change of variables, use substitution. This is the pattern recognition version. If you want the use substitution version, go ahead and go to the other video. Okay, the links should be right next to each other in Schoology. All right, so this is the pattern recognition match. All right, this is page 260 of your Incredibles book. Okay, so the pattern recognition is, I look at here, x squared plus 1. What is the derivative of this inside function? Right, so this is the opposite of chain rule. Remember in chain rule, the derivative of the inside function pops out, right? It comes out. Right, so let's review real quick. If I have the function x squared plus 1 to the fourth, if I take the derivative, well, I should do a fifth. If I take the derivative of that, that becomes 5 times x squared plus 1 to the fourth, and then take the derivative of the inside, and 2x pops out, right? You have gotten used to this, and you don't ask me, where does that 2x come from, right? So this is the opposite. So here we have this 2x, which is the derivative of x squared plus 1, and when we integrate it, so we're going to add 1 to the exponent and divide by the exponent, but the derivative that popped out pops back in, so it's gone. So we use that 2x as part of reverse chain rule, okay? But it's called use substitution or pattern recognition. That's example A. That's the answer to example A. That's it. Here, look for the derivative of something somewhere else. So here, what's the derivative of 3x squared? It's 6x. There's no 6x lying around. What is the derivative of x cubed plus 1? 3x squared. So there it is. So that's going to be absorbed when I integrate this. But let me do a rewrite first. 3x squared, x cubed plus 1 to the 1/2 dx. So now I can do regular power rule and absorb the 3x squared. So that's going to be x cubed plus 1 to the positive 3/2 over 3/2. And that 3x squared was absorbed, okay? I'm going to rewrite this better. So it's 2/3 x cubed plus 1 to the 3/2 plus c. All right. C, okay, here, what's the derivative of secant squared? Well, the derivative of secant squared is 2 times secant squared tangent x, and that's not what it is. But what is the derivative of tangent x? It's secant squared. And then you might be wondering, what do I do with this plus 3? Well, what's the derivative of plus 3? It's 0. So if I treated this as if it were an exponent, so what's the derivative of tangent x plus 3? Well, it's secant squared. So now I can do reverse chain rule and treat that 1 as the outside function. So this becomes tangent x plus 3 to the second power divided by 2 plus a constant. That's the answer to example C. And if you think about it, just take the derivative of this. What's the derivative of this? Using chain rule, you bring down the exponent, which would cancel with this 2, right? And what is the derivative of tangent x? It's secant squared, so that's what's left. So it's secant squared times, you get this whole thing back. Okay, that was the whole point of that. All right, D. We got 7e to the 7x dx. The derivative of 7x is 7. So when I integrate this, it's just e to the 7x plus c. These are a little harder to see because it's so simple, right? Sometimes the simplest things are most difficult to understand. And this is easier to understand with use substitution if you want to go look over there. All right, E, example E, 3x squared. So look for the more complicated version. Here, x cubed plus 4 to the second power, and in the denominator of a fraction, that's the most complicated part. What is the derivative of x cubed plus 4? Well, it's 3x squared, so there it is. So I can do this by the pattern recognition. So that's I'm going to rewrite this. 3x squared, x cubed plus 4 to the negative 2 dx. So x cubed plus 4 to the negative 2, I am going to use power rule on that. So it's x cubed plus 4 to the negative 1 divided by negative 1. Remember the derivative is absorbed, so that's gone. Plus c, let's write that a little better. It's going to be negative 1 over x cubed plus 4 plus c. Sorry for the handwriting. All right, here we go. What's the derivative of 2x minus 3? It's 2. So that's an exact match. So power rule on that. So it's 2x minus 3 to the 4 over 4 plus c. Can't really clean that up much, so we'll leave it just like that. G. What is the derivative of cotangent x minus 4? So this one is not obvious because this is not really inside something, but you can think of it as it's inside the exponent of 1. Derivative of cotangent x is negative cosecant squared, right? So that's it. So you might think this is the more complicated one, and you're being right. However, the derivative of negative cosecant squared is not this, okay? So it's not here. So I'm going to reverse that. So that's going to be cotangent x minus 4 to the second over 2 plus c. The derivative of negative cosecant squared is absorbed. So that's the answer. H. Here, what's the derivative of x to the 4th plus 9? It's 4x cubed. All right, so that means I can do a rewrite of this real quick. So that's x to the 4 plus 9 to the 1/2 dx. Right now, use power rule on that. So that's going to be x to the 4 plus 9 to the 3/2 divided by 3/2 plus c. Remember that 4x cubed is absorbed. So rewrite that as 2/3 of x to the 4 plus 9 to the 3/2 plus c. And that's that. I'm going to go ahead and we stopped much earlier in class, but I'm going to go ahead and do this one. All right. No. Okay, I'm going to stop right there. And I'm going to do the other version.